So a ball is thrown from a building. The distance of the ball above the ground in feet is given by the function d of t, where t is measured in seconds. And the first question, part A, asks, what type of roots do you expect to have? Now, before we get into that, I think it is very important that you identify the variables. It's something that we have kind of struggled with, and it will come back to really help us. So just to keep in mind, d, the dependent variable, is the distance above the ground. It's important. And then t is, of course, the time. All right. So what type of roots would I expect? Well, let's just kind of wrap our head around this problem. We have, some building. We have a ball that's thrown off the building, and it eventually, will smack into the ground, unless it's some special kind of ball. So what is the ground? Well, the ground is the x-axis, because the distance above the ground when it hits the ground would be 0. And so the type of roots I would expect, well, I will expect 2 real roots. What's my reasoning behind this? Well, real roots means that my parabola will intersect the x-axis. And in this case, the x-axis is the ground. So I will undoubtedly expect real roots. Next, I am asked to figure out when the ball will hit the ground. And so it's important to realize what the question is asking me. The question is asking me when the ball hits the ground. In other words, when is a time, right? So I'm looking for the time. That's what I'm looking for. When is the distance, d, when is d 0? When is the distance above the ground 0? And so what I'm going to do is I'm going to set my function equal to 0, right? I'm looking for the roots here. So I'm going to set my function equal to 0. So I have d sub t is equal to, and I would write out my function here, and I'll set it equal to 0. Now how am I going to solve for this t value? What t value will make the distance 0? And here we can apply the quadratic formula to solve. And so I would apply the quadratic formula. The quadratic formula, of course, is negative b plus or minus the square root of b squared minus 4ac, and both sides are divided by 2a. Right? And that will give me 2 roots, and make sure that you choose the one which makes the most sense. All right? But it is very important to make sure that we set everything up. We realize that we're searching for when the distance is 0, and we solve using the quadratic formula. Now C wants us to figure out what's the maximum height that the ball is going to reach. What is the highest point that it will reach? And the highest point of your parabola is your vertex. So what this is looking for is, what is the vertex? Well, the vertex occurs at negative b over 2a, right? Remember, this is where the vertex occurs because on either side of it, so let me just kind of draw that here. So if the vertex occurs here, the roots will occur on either side an equal distance away. What's that equal distance? Well, that's given by whatever I'm adding or subtracting, which is either, it's going to be the same thing, and I'm either adding it or subtracting it. So in finding our roots, we've actually already found where the vertex occurs. So the time value where the vertex occurs is negative b over 2a. We've already found that. And then to figure out what the vertex is, well, we will plug this into our function. So d of whatever it is that this happens to be will give us the value of our vertex. Lastly, the question says, imagine that instead of throwing the ball from wherever you did throw it, you threw it from 35 feet above the ground. Write a new function that would model this situation. So we have a new function, it's called d sub 1 of t, and it's thrown the exact same way. The only difference is now that the ball is thrown from 35 feet above the ground. Well, what represents where the ball is thrown from above the ground? That would be this initial value here. So everything else will stay the same. Negative 16.1 t squared plus 37.9 t. And now I'm going to add 35. That's going to be my initial value. This is the key change here, and that is going to be my function.